All right, Chem students, video 4. Here we go. Naming acids. I feel like this video needs a warning label or a short little "it'll be okay" before we get started. Everybody hates acid nomenclature. For whatever reason, it's the one that people struggle with the most. And I'm trying really hard to ease you into binary, ternary, things like that. But with acids, this gets really, I don't know, more detail oriented. I think it just takes practice. So hang in there. If you absolutely hate these at first, or if it goes way over your head, that's normal. Everybody hates these at first. But hopefully, after a little practice, acid nomenclature won't be so terrible. So fingers crossed, here we go. Okay, acids are composed of the hydrogen cation followed by an anion. So the good news is it always starts with hydrogen, so they're easy to identify, but then the anion can either be a nonmetal or a polyatomic ion, and that's where we have a hard time naming them, but I'll explain that in a little bit. Okay, so there's 3 rules for naming acids. Let's do the easiest one first. So the first one is for binary acids, meaning the anion is a nonmetal because the cation is always hydrogen. So no big deal, hydrogen check, acid. But the name of acids is always based on that anion because that's the only way it's different, or that's the only way they vary. Okay, so if you have a nonmetal as your anion, it's going to be a hydroblankic acid. Take the root from the anion name and fill it in the blank. So this is what I mean. HCl. So Cl is the anion, which is chloride. So the name is hydrochloric acid. HF. Fluoride, so hydrofluoric acid. Pretty simple. The way that I look at these is if the anion is on the front of the periodic table in this little section, over here, our little white friendly nonmetal section, these are hydroacids. Okay, let's go on to rule 2. All right, rule 2 involves ternary acids, but these polyatomic anions are going to end in ate. So phosphate, for example. So they're going to take the root from the anion name and fill in the blank. So to help you remember that ate turns into ick, we have this little saying, what I ate was icky. I know it's silly, but it's going to help you. I promise. I have all these little silly things, but you will not forget what I ate was icky, and it will change your life. So here we go. If we look, this guy is obviously an acid because it starts with hydrogen. If we look up NO3 on the back of our periodic table, in this little section here, we've got our polyatomic ions. NO3 is nitrate. So it's not going to be nitrate acid. You're going to take the ate off and change it to ick. It'll be nitric acid. Okay. CO3 is carbonate. So I'm going to change the ate to ick and have carbonic acid. Okay, note, did I say hydro? I did not. So here's the big deal. Front of your periodic table, hydro acids. Back of your periodic table, no hydro. Front, hydro. Back, no hydro. I promise it'll help. Okay, at the bottom, note, when the anion contains sulfur or phosphorus, the roots are sulfur and phosphor, respectively, not sulf and phos. So H2SO4 is sulfuric acid, not sulfic acid. H3PO4 is phosphoric acid, not phosphic acid. Highlight that, underline it, make it look super important because that's a silly mistake. I don't want you to make that on your test. Okay, moving on. Our third rule is still for ternary acids. So that anion, again, is going to be on the back of the periodic table, but it's for polyatomic anions ending in ite. The rule is the snake bite was poisonous. So ite changes to us this time. So H We know it's an acid, NO2. NO2 is nitrite. So nitrite turns into us, so nitrous acid. And please don't forget to add the word acid. This is not nitrous, it's nitrous acid. Okay, ClO2 is chlorite, which changes to chlorous acid. Okay, so little recap before I move on. If you just have a binary acid, meaning that the anion is on the front of the periodic table, these are your hydro acids, hydroblankic acids. Then, if you've got a ternary acid, meaning it contains a polyatomic ion from the back of the periodic table. Remember, what I ate was icky, and the snake bite was poisonous. There's no hydro in these, just ate to ick and ite to us. Okay, here's some practice. So HBr, just binary, so hydrobromic acid. On the right side, H2SO4. This is sulfate, so what I ate was icky. This is sulfuric acid. Pause the video, try these on your own, and when you come back, I'll have the answers for you. Okay, number 2, H2S. Well, S is not a polyatomic ion. This is binary, so hydrosulfuric. H3P, hydrophosphoric acid. So notice the anions are on the front of the periodic table, so they are hydro acids. On the right, we've got ternary because we've got these polyatomic ions. So sulfate turns into ick, sulfuric acid. This one's sulfite. The bite was poisonous, so it's sulfurous acid. So sulfurous, sulfuric, the only difference is one oxygen. Okay, and then lastly, H3PO4. PO4 is phosphate, so this is phosphoric acid. Do not get that confused with hydrophosphoric acid, which is just phosphorus, not the polyatomic ion, phosphate. Okay, hopefully this makes sense to you. If not, make sure to pause the video and ask your teacher for help. Let's move on. Okay, here's the easy part. So writing the formulas is easier than naming them because for acids, all you've got to do, just like ionic compounds and just like bases, is to crisscross the oxidation numbers. Reduce if necessary. Same old, same old. What's nice about your acids here is that your cation is always going to be hydrogen. No surprise. We've always got hydrogen. So let me do a couple examples. We've got hydroiodic acid. Well, because it's hydro, I know it's binary, so iodic just comes from iodine. So +1, -1. If the oxidation numbers are the same, you just smush them together. So HI. Hi, I'm hydroiodic acid. Next one, we've got chloric acid. Okay, there's no hydro, so what I realize is this is ternary. It contains a polyatomic ion. What I ate was icky, so I'm looking for chlorate, which is ClO3 with a -1 charge, +1, -1. They cancel and smush them together. Let me look for one we have to crisscross. Let's do phosphorous acid, this last one. Phosphorus, the bite was poisonous, so I'm looking for phosphite. PO3 with a -3 charge. I'm going to crisscross. This 3 is going to become the subscript for hydrogen, so I get H3PO3. You know the rule. Pause the video, try these last two, see how you do. Okay, welcome back. Chlorous acid. The bite was poisonous, so I'm looking for chlorite, ClO2 with a -1 charge, +1, -1, HClO2. Phosphoric acid. What I ate was icky, so I'm looking for phosphate with a -3 charge, crisscross, H3PO4. I hope you did well on this. If you missed them, raise your hand and ask your teacher for help. So as you can see, naming acids can be a little tedious. There are 3 rules. They're not terrible. You just have to know the difference between the 3 different kinds. But writing their formulas is super easy with crisscrossing, which you should hopefully be a pro at this point. So stick with it. Do your acid practice in your practice packet. Ask your teacher for help. You're going to be a pro. Have a great day. Bye.